This lesson is on Intro to Trigonometric Ratios, and it is geared towards students taking Math, CST, and Sec 4. There's a few things that you need to know before we begin talking about the trig ratios. First, you should review about your angles. You should know that the sum of the measures of the interior angles of a triangle is 180 degrees, that two angles are complementary if the sum of their measures is 90 degrees. For example, these two angles are complementary because 31 plus 59 degrees equals 90. You should also remember that two angles are supplementary if the sum of their measures is 180. So here's an example where you have 120 and 60, and if you add them together, they equal to 180, so they are supplementary angles. You should also know how to deal with proportions before we do trig ratios. So for example, these two shapes here are similar. Their corresponding sides go with CD and GH, and then AD and EH. And because they are similar, we can use what is called the scale factor or the similarity ratio. Therefore, if I do 5 over 6 and 3 over x, I can cross multiply to solve for x, and I would get that x is equal to 3.6 centimeters. Also, something that I teach in my classes is the fish method. If you just do 3 times 6 divided by 5, you'd get the same answer. We're about to start trig ratios, but before we do, just a very friendly warning. Everything in this lesson deals only with right angle triangles, and you need to know how to cross multiply, what I just showed you in the last slide, either the fish method or actually cross multiplying algebraically. First, what is trigonometry? Trigonometry is the study of the relationship between the angles and the side lengths of a triangle. Using trig properly will help determine all the side lengths and angle measures of any triangle. Before we begin, you should find on your calculators the sine button, the cosine button, and the tangent button, abbreviated sin, cos, and tan. You should also make sure that your calculators for this lesson are set to degrees or deg, or sometimes it's just the letter D. Basically, it cannot be in radians. We're going to talk about the importance of labeling your triangles, and in this case, this is a right triangle that I have labeled ABC. But for the purpose of this lesson, you must label your sides with the words opposite, adjacent, and hypotenuse. These labels depend on which angle you are focusing on. In our case, we have angles A, B, and C to choose from. If we are focusing on A, here is how we would label the sides using the three words I just introduced to you. This would be the hypotenuse. It's the longest side of a right angle triangle. The BC is the opposite side from A, and AC is adjacent to A. Another word for adjacent is beside of. And although we have two lines beside A, the hypotenuse is always the hypotenuse. So this side has to be the adjacent side. What if we focus on B instead of A? AB would still be the hypotenuse, but now we have BC as the adjacent and AC as the opposite. Notice that the hypotenuse is always the same no matter which angle we are focusing on. What really changes is what is the adjacent and opposite side. Why are we not going to focus on C? Just a few reasons. One, if you'll notice, the opposite side for C is the same as the hypotenuse, so we have a bit of an issue here. This would mean we would have two adjacent sides, in this case AC and BC. Also, when we are using trig ratios, specifically cosine, we cannot use cosine of 90 because it equals to 0, and that makes it impossible for us to solve any angles or side lengths. So please never focus on the 90-degree angle when you're using trig ratios. First, we're going to talk about sine. The sine of an angle is calculated by dividing the opposite side of that angle over the hypotenuse of the triangle. So here is a similar triangle that I gave you in the last slides. sine of A is equal to the length of the leg opposite over the length of the hypotenuse. And the sine of C is equal to the length of the leg opposite C over the length of the hypotenuse. To help you remember what we need to divide, we use the term SAW, where sine of an angle is equal to the opposite side of that angle over the hypotenuse of the triangle. Here's an example. I have given you 3 side lengths of this right angle triangle, and I am asking you what is sine of E. The first thing that we should do is we should label our sides according to angle E. This is the hypotenuse, this is the opposite side from E, and this is the adjacent side from E. If we are calculating the sine of E, we use SAW, so we're going to do opposite over hypotenuse. In our case, the opposite side is 12, and the hypotenuse is 20. So we have just calculated that the sine of E is 12 over 20, which is equal to 0.6. What does solving for sine mean? Since we solved for sine, we got that sine of E was equal to 0.6. In the next lesson, you will see how solving for sine, cosine, and tangent will help you with angle measures. Now let's look at cosine. The cosine of an angle is calculated by dividing the adjacent side of that angle over the hypotenuse of the whole triangle. Here's another similar triangle labeled ABC. And if I was talking about the cosine of A, it would be the length of the leg adjacent to A divided by the length of the hypotenuse. Or if I was focusing on C, the cos of C is the length of the leg adjacent to C over the length of the hypotenuse. In order for us to remember what to divide, we use the word CAH, where C is for cosine and AH is adjacent over hypotenuse. Here's an example. Same triangle, but we're going to label our sides looking at E, focusing on E, and we are going to talk about cosine, which is CAH, or adjacent over hypotenuse. We're going to plug in what we know. We know that the adjacent side is 16 if we're focusing on E, and we know that the hypotenuse is 20 if we focus on E, and therefore 16 divided by 20 tells us that the cosine of E is 0.8. Remember, your acronym for cosine is CAH. Finally, we have tangent. The tangent of an angle is calculated by dividing the opposite side of that angle over the adjacent side of the triangle. And in this case, here's an example. If I focus on A, it would be tan of A is equal to length of the leg opposite A over the length of the leg adjacent to A. And tan of C is the length of the leg opposite C over the length of the leg adjacent to C. You'll notice that tangent has nothing to do with the hypotenuse. It's the only ratio that doesn't need the hypotenuse. In order for us to remember what to divide, we use the word TOA, where T is for tangent and O and A are opposite over adjacent. Here's an example. Same triangle, but we're going to again label our sides according to E. And we're asking for the tan of E, which is TOA. So tan of E is equal to opposite over adjacent. And we're just going to plug in what we know. So tan of E is equal to 12, because that's the opposite side, over 16, which is the adjacent side. And that tells us that the tan of E is equal to 0.75. Here's an important recap for SAW, CAH, and TOA. This is what we use. Sometimes instead of saying trig ratios, we say use SAW, CAH, TOA. SAW, CAH, TOA is the way for you to remember what your trig ratios are, where S, C, and T represent sine, cosine, and tangent. O, H, and A represent opposite hypotenuse and adjacent sides. What does this have to do with angles? Trig ratios help you find the side lengths of triangles when the angle is given to you. So here's an example. For the first time in this lesson, I've given you an angle measure. The question is, find all the angle measures and side lengths of this triangle. You already know, though, by the sum of the interior angles of a triangle, that you can find angle GHI by just subtracting 35 and 90 from 180. And we get that 55 is angle H. For the sides, please don't hesitate to use Pythagorean theorem. You can do that with a right angle triangle. But in this case, you can't use Pythagorean theorem because you only have one side. Here's a way for us to look at a right angle triangle and use trig ratios to find a side length. the very first question that you need to ask yourself though is what angle would you like to focus on? For this case, we're going to use 35 degrees. And because we are focusing on the 35-degree angle, we need to label our sides according to it. In this case, this is the adjacent, this is the opposite, and this is the hypotenuse for the 35-degree angle. Because we have the adjacent side, let's use CA or TOA. But because we know that we're trying to find the hypotenuse in this case, we're going to use CA because it includes the adjacent side that we have and the hypotenuse that we are looking for. This is where your cross multiplication skills need to come in very handy. This is what we would set up our ratio to be as. CA, cos of 35, is equal to the adjacent side over the hypotenuse. You could right now plug in cos of 35 on your calculator and round if you don't want to do it all at once. And then you would do the fish method, which was 5 times 1 divided by the cos of 35, which tells us that the hypotenuse is 6.01 centimeters. Now, if you wanted to, because you have two sides, now you could use Pythag to solve for the opposite side, or GH. Try it yourself. Using the angle of your choice, find side GH using trig ratios. Follow the following steps. You first focus on an angle, you label the sides according to that angle, and you decide whether you will be using SOH, CAH, or TOA. And finally, you're going to have to cross multiply your ratios to solve for whatever GH is equal to. Here are the answers. If you focused on 35, you would have something that looks like this, labeled, and you would use TOA because you are talking about adjacent and opposite sides. You would cross multiply 5 times the tan of 35 divided by 1, which gives us that GH is 3.5. If you decided that you were going to use the 55-degree angle, this is how you would label your sides, and you would use TOA, but in this case, you have that the tan of 55 is equal to opposite, which is 5, over the adjacent, which is GH. So if you're using the fish method, you would do 5 times 1 divided by the tan of 55. In the end, you get the same answer, which is 3.5 centimeters. And you'll notice that for neither of these answers, I used the 90-degree angle. The importance of angles. Notice that once we have just one angle of a triangle on one side, you can always find the other side lengths using trig. If you focused on angle I, 5 centimeters is the adjacent side, so you can use CA or TOA. If you focus on angle H, 5 centimeters is the opposite side, and you can use SAW or TOA. Find the missing angle measures and the missing side lengths of this triangle. Try using trig ratios as much as possible. Remember to focus on an angle and label your sides according to it. Here are your answers using angle Z. So if we focus on angle Z, we would label it according to that angle. And we can use CA or TOA first. I used CA, so I said that the cos of 24 is equal to the adjacent over the hypotenuse to solve for the hypotenuse. And this is what I get for the hypotenuse. Then I decided that I was going to use TOA, so opposite over adjacent, to find XY, which is the opposite side, and I get that the opposite side is 7.12 centimeters. Obviously, you could have used Pythag when you were done, say, this part here, but for the purpose of this lesson, I wanted you to use trig ratios as much as possible. Here are the answers if you used angle X. If you used angle X, you had to do 180 minus 90 minus 24, which gave you 66 degrees. Then you would have to label your sides according to that 66 degrees. First, I used sine to find the hypotenuse, where I said sine of 66 is equal to the opposite side over the hypotenuse, and I solved to get 17.58 centimeters. Then I needed to solve for the adjacent side, which tells me that I'm going to use tan of 66, which gives me opposite over adjacent, and I get that XY is 7.12 centimeters. You get the same values as the last slide, and just like the last slide, you could have used Pythag the minute that you got two sides completed. So here's just a final recap. Our first trig ratio is called sine. We nickname it sin or we still say sine, but it's written sin. The proportion is opposite over hypotenuse, and we use the word saw. We also have cosine, where if you were to go on your calculator, it's cos. Its proportion is adjacent over the hypotenuse, and we use CA. Finally, we have tangent, whose nickname is tan. The proportion is opposite over adjacent, and we use the acronym TOA. And that is the end of your lesson on trig ratios.